Hello everybody, I will talk today about the Lean Patent Canvas for Innovators, a methodology I invented myself or I tried to develop with all these kind of customers I've been speaking to during several years. Just to represent myself, I'm Cosaert. I'm from background an engineer in electromechanics, already graduated early 90s. And from the beginning, I was involved in innovation because the first 15 years of my career, I've been working on material research, electrotechnics, and for several customers, it was a kind of applied research. I had the possibility to visit customers to understand what the product was used for and how my company could then change the product to have a better performance. And then since 2007, I changed to become an innovation consultant, and I had the opportunity to talk with many SMEs, many startups, many innovators about their process, their project planning, but also a little bit about their IP strategy. Because if you want to conclude my expertise and the way I look at things and process and innovation, it's always a combination of innovation, entrepreneurship, and IP strategy. And I'm always product process focused. So it's a kind of approach which I find it very important to combine these three elements whenever I deal with innovation. And in fact, it's when talking to that many startups, that many inventors, these questions and answers that along the years, I built up two kinds of frustrations in my talks with these persons. And first of these frustrations is all about patents. I have to read lots and many patents for customers, for inventor startups, and I see so many patents where I wonder what is the real economical value of a patent. If you see here on the left-hand side, you have the build-up of a hamburger, what is very nice to see, but what is the technological invention of this? Just by layering up elements, maybe you could have had other IP rights that were better, less expensive. And then on the right-hand side, you have this basket with the holes in it, to serve a basket probably for warm materials which are inside or for better ventilation. But to me, if you see the value, the cost of such a product, why did you invest that much money into a patent? This is the kind of frustration. Also, yes, some patents are very interesting to see. You have very nice drawings in this patent database, but if you see the value of this kind of patent, it's now used today to discuss whether toilet paper should turn forward or backward. But what was the reason, the value, the motivation to obtain that kind of patent, and how did it serve for a better income for this company? And then on the other hand, you see a lot of patents where the emphasis on the product itself is so high that they forget that maybe the invention is rather in the methodology than it is in the product itself. And like for the present, the picture you see here, we have rather a methodology about the orifice that was the invention and not the product. A therapeutic product has no real meaning in this kind of patent. And also one of my customers, which developed a kind of cable trays, which really in fact cost only 10 cents, came up with a patent of 40,000 euros, a European patent. And then I told them, how many of your cable trays do you really have to sell in order to regain the investment of your patent portfolio? So this is a kind of frustration I take with me along all these talks I had. And the other part is that although I believe it could be very valuable, I'm convinced that the emphasis on customer centricity nowadays is too high. It means that whenever you have an idea on invention, due to this customer centricity, we are forced to talk only about that customer. We have to apply further research, further development for that customer. And sometimes we forget the real value, the technological pivoting may be possible. Because if we focus on that first customer, we forget everything else. We see that first flower blossoming and we only make that one nurture. But to me, any innovation, any product development, I always compare it to a train that is built out of wagons. And a train can drive any direction it wants. And you can change wagons at any time you want. And it's the same with a product. A product is built of modules of kind of wagons that are interchangeable. Suppose a new disruptive technology is coming up, maybe you can have a sidetrack where you change one wagon to the new disruptive technology, and once it's mature, once it's very good developed, you put that new wagon into your train again, and it can keep on going. It can go to another direction, another market, but you don't lose that time. The time where we do product development starting from zero again, that has finished. We need to keep on going, keep on looking what kind of new technologies are popping up. Yeah, I'm very much interested in this technological entrepreneurship. And so for me, with this kind of two frustrations and all these discussions I had with these customers, I tried to understand. I did some research on what happens and how did the translation happen from that idea to that result, to that patent, to that market focus, and where did they forget to look somewhere else, to look whether pivoting or scalable elements were possible. And so I needed to do some further investigation to understand, because for me, it's a kind of automated process and I can immediately define the solution, but I want the inventor or the company himself or herself understand and be able to find the scalable solutions themselves. So if I then look about ideas, how I wanted to see if I have an idea, how does it grow, how does it scale? And for instance, this example here is about duct tape. And duct tape in its origin was not the duct tape as we know today. No, in fact, in the early days when the army went to war, they had a problem with moisture. And so the guns and the bullets, they had problems to keep them dry. And the army asked, I think it was Johnson & Johnson, to develop a kind of tape that made it able to protect the guns and bullets towards moisture and wet conditions. And so they come up with the kind of tape. In that time, it was rather a brownish color, and that's why the soldiers called it duct tape, because it looked like a duck at that time. And so the tape existed, but it was only when the soldiers came home and they had some of that tape with them. And you know, when you've gone away for a long time and you come home again, probably you will have not a lot of repair works to do. And so they discovered that this tape they had with them, that they used in the army times, that they could use it to resolve some problems in plumbing, that they could use it to connect two pipes again without having leakages. And that's when really the growth of duct tape happened, because somebody saw what was going on and saw the possibilities and saw the solutions. This is one example. Another example is like the Frisbee. Do we really believe that the Frisbee existed or happened all of a sudden, that somebody discovered a plate, threw it to somebody else and said, this is a Frisbee? Yeah, of course, this is not the case. This is not what has happened. In fact, what was the reality, that there was a huge famous bakery next to Yale University, and this bakery made some very good cakes, but they served them on a silver plate. And lots of students from Yale University bought their cakes with this bakery, and they discovered that the tin plate, well, since they had it, they start using it to throwing it to each other. And so that was the real origin of Frisbee. And where did the name come from? Well, the name of the bakery was Frisbees. And so you see that these innovations, these ideas, they just happen by accident. It was designed, developed for one purpose, but all of a sudden, by accident, somebody discovered that it could be used for something else. And there you see growth happening, scalability happening just by accident. Does it mean that all the ideas need to happen by accident or just by that? No, sometimes we can see that there is a strategy behind it. If we look, for example, to the origin of the foam mattress we know today, called Tempur, it has its origin because NASA sent some astronauts to space, and you know, these astronauts, when they are launched into space, they have to they suffer enormously from G-forces. The acceleration strength is very high, and this is for the body of an astronaut a very severe condition. So they asked to develop a kind of viscoelastic foam to help these astronauts survive the route towards space. And once this viscoelastic foam was discovered, well, was invented, developed, one can only think about using it for impact or shock absorption, because the question was solving the issue of acceleration. And it was only when the patent was released, I believe about 20 years later, that somebody in Scandinavia said, but instead of using that foam for impact or shock absorption, what if we use it for people that have to lie in their bed for longer periods, and we want to have them a better support, we want to have less wounds when they are a long time in bed. And so they changed and they used this viscoelastic foam just for a mattress and no longer for impact or shock absorption. And it became a huge success, and it became a very growth adventure and a growth story for this company. Another one for Listerine. Listerine was really invented to disinfect chirurgical utensils, but that was not such a huge success, and there was not such a huge amount of Listerine needed to clean this kind of utensils. And it was only since somebody saw and investigated that it could be used to rinse your mouth, to have better, to protect your teeth, to protect your mouth, that it took a huge turnover, and that Listerine became that important product as we know it today. Another example was, for instance, Teflon. And a long time ago, somebody looked for a polymer that was slippery, that was very inert, but they had, and that was the product called Teflon, and it's used in industry where you have to glue material together, but you don't want it to be glued to the metallic surface or whatever. You put this Teflon layer in between. But it was only until a French engineer found a way to connect this Teflon to aluminium that the Tefal cooking pans were there, and they took over the market, and they found a new approach, a new growth, a new scale. So you see all these elements. That means that somebody had the guts, had the feeling that he could pivot, he could change the application, he or she could change the way it is used and the way it's always been done. And he or she re-questioned what was happening. And that's just maybe something we need to do more and more to find the scalable growth within our ideas. So let's take an example, because we know today, we all suffer from this COVID pandemic, and so we all know that having air support for patients in hospitals is a very, very important topic. So from the beginning of the COVID pandemic, you had some technologists trying to find solutions to divide air support to more patients than ever before. If you only could serve 5 patients, why not try to increase and improve your technology that you could help, instead of 5 patients, 10, 15 or 20. And you saw in the beginning of the pandemic some technologists finding solutions to really divide on a proper way this kind of this air to patients. And then, okay, you have invented, you have this idea, you have this technology, but what do you do if you were the inventor or the technologist that came up with that solution? Well, then it's about making a choice. It's about what kind of focus will you choose? And you have several directions. And one is you say, okay, I have a focus. I know this was an urgent need, this hospital, this air supply in hospitals. So I will only focus, customer centricity, I will only focus on this air supply. But on the other hand, you can say I'm a technology company. I will keep on developing this technology because air is the same as gas, is the same as water. It's all about having a divided laminar flow. So maybe I stick to my expertise and I will investigate further on technology. But then you can say, what about these hospitals? Well, let's find a product design company that makes the housing of this air supply and build something that can be used in a hospital. And maybe you can then do the business development together with this product design company to serve the hospital market. Meanwhile, you're doing investigating for other sectors or other markets. It's all about choices. And so I understand this is a kind of roller coaster, and me talking about pivoting and changing technology is often for many startups a very strange thing to do, because they're not used to it, it's not feeling comfortable. But nevertheless, it's important to rethink what we're doing and sometimes find what is the innovative jewel within our story and within our ID. So that's the part about how an ID grows to and becomes scalable. But on the other hand, I still have this IP issue. I still see that you have so many companies that are not aware about intellectual property. They do not understand the difference between a trademark, a registered design, or a patent. And you lose too many time if you have to explain it to a company when you're in an innovation process. You only have to tell what is important. And it's the same about patents. If something is worth patenting or not, sometimes you lose too much time in explaining what is a patent about, and certainly about explaining about the procedures, because in an innovation phase, you do not need to know about procedures, you need to know about patent claims. And also, there is a kind of, well, sometimes people say there's a trust issue, but you have to be aware that a patent specialist or a patent attorney, he's not an entrepreneur, so he's not aware about entrepreneurship. And you need to know how you will do business with your ID. And that's something this patent attorney cannot tell you, cannot explain you. So this is, I've been, as a translator, I call myself a translator in this matter. I've been involved in many talks between inventors and patent attorneys, patent specialists, and you see there is a different way of communicating. They don't seem to speak sometimes the same language, and me as I understand both worlds, I need to translate often what is said. And also, one of the issues that is, the highest degree for any inventor is to obtain a patent. And sometimes they are so blindsided because they really want a patent. Nevertheless, even if it's economically not viable, having and obtaining a patent is for them having proof that their ID is a real ID, is a real invention. But still, there should be an economical viability for any patent, but you have to deal with this kind of issues. And so for me, knowing all this, doing this kind of research, I said, okay, I have to start to build my canvas, my own canvas. I know about the lean startup, I know about the business model canvas, but I felt that in this innovation phase, in this R&D phase, there's still a lack of a kind of tool, a kind of canvas that makes IDs pivotable, scalable, and make IDs stronger, because there's so many value in IDs which people don't see. And so I said, instead of giving solutions to customers, I will build a canvas so I can teach them to find the solution themselves with a canvas. And that's, well, my blank canvas. So in the beginning, it was very easy. I could come up with words as customers and problems, solutions, typically reverse engineering, IP background. I have lots of topics, dimensions that are important in this phase, but the biggest struggle to make a canvas work is also to how do you combine the elements and how do you make that the exercise flows from one thing to another. And because I have to deal with some topics that are not so comfortable for an inventor, but they are important. And that's why at that time, during my research, I came up with this research done by Jerks-Dodson law. And it's a kind of research where they look how can you increase the performance of a person. And it seems, but maybe it sounds obvious for you, it seems that if we're not under stress, we're not performing that well. If there is a little amount of stress, not that much, but if there is an amount of stress, we tend to perform much better. But we have to take care, because if we put too much stress, we tend to go towards burnout, we tend to go towards anxiety, and then performance drops down. And so I had to understand within my dimensions, within my building blocks that I use for my canvas, which elements do belong to a comfort zone, which elements do belong to the stretch zone of this inventor, and which elements are really in a panic zone. Because then I understand that the elements need to be placed in a well-shaped order. And so finally, I came up with my lean patent canvas for innovators, and I used the methodology of an iceberg to really give shape to the canvas. And finally, my lean pattern canvas looks like this. And you see, anything above the water is what you are allowed to talk about to your customers, to other people. Everything below the water is information you have to keep for yourself, because innovation has to do with secrecy, has to do with elements that cannot be told to other people. So there is much more from innovation that should be below the water than above the water. Because I see so many startups, they are so proud of what they're doing, they're telling everything, but they need to be aware about what they can tell to their customers and what they are better keep quiet or keep under trade secret. And so the idea of the innovation iceberg means that the better you investigate your idea, the stronger the value of this idea. Because as you know, an iceberg, only 10% of an iceberg is above the water, 90% is below. So the exercise means that we need to increase this 90% in order to shine above the water and to really build a strong value proposition towards our customer. And also the model is built in that way that on the left-hand side you will find elements that will help you to build later on your patent claims and to build your secret know-how. Because this lean patent canvas not only makes your idea 10 times more valuable, it also gives you as a bonus a patent strategy, which is very important for any innovation, for any starter, for any idea, if you want to make your business grow. And so then we have this research on Jervis-Dodson law. The elements, the dimensions of the canvas are built in that way that the elements belonging to a kind of panic zone are on the bottom of your iceberg, the stretch zone is in the middle, and on top, just below the water, there is your comfort zone. And so it's a model that has been tested with several startups, several companies already. It's functioning quite well. It makes them rethink about their idea. It makes them change or rechange some of the ideas, and that's why I think it's a methodology that could be useful for many people, and I believe some of you might be very interested in this methodology, because this is how the methodology looks like. But I can understand that this is rather theory and it gives you a lot of elements, and maybe you're now wondering, but make it more practical, what does it really mean? So let's start with an example. What about your idea? And I took one example, and I call it my light buddy. I have this kind of idea. Let's say I have a starter that is coming to my office, and he's talking about his idea, and the idea is he wants a light, he wants to make a light buddy, and this light buddy is a light that he does not have to hold in his hand, but it's a light that follows him or her wherever she goes. And so if I need to describe my idea or invention, I say, well, I've seen these fireflies and I see how they work, and I was inspired by these fireflies, and that's why I wanted to build this idea, to make a real life firefly that follows me wherever I go. So I want this lighting device, and as I'm into technological entrepreneurship and I know about these disruptive technologies, I know that drone technology should be mature enough to realize this. I know that there are recognition systems so that the aspect of following must be doable. Technology is there, I think, and the startup will tell me, I think I can make it, I can start doing research, development, product development. And that is what in reality happened. This startup with that kind of an idea, with that kind of mature technology, he hasn't seen the solution around where he was looking. He didn't see it with his friends or within in his neighborhood. Probably he didn't look that far on the internet to see whether it exists or not. But as he knows about drone technology, or he could find something about drone technology, he can find something about recognition systems, he can start building it because he has a customer, himself or herself, she's a customer. So why not making it immediately, customer centricity? And I say, well, maybe let's do the exercise first. Let's have a deeper look in your idea and what could be the value of your idea. So we're talking about asking questions about the comfort zone of an inventor. And so the questions about the comfort zone are, who's your competition? And then you will have, in this case, answers like, well, the people building lights, fixed lights, you have the flashlights, you have the street lights. And also you get questions about, yeah, but from competition, what kind of solutions you didn't like? What are the problems you have with this competition? And then you will hear that they don't like that lights are fixed. They don't want to hold a flashlight. And street lights, they make them follow a directed route, and they have no choice in where they want to go, and they want the freedom. And so we understand a little bit more about the background of the idea and how it is amongst competition. But then knowing about this, if once we know about the problems they wanted to solve, because we asked them, well, okay, if you have these problems, how will you solve it? Then we can start talking about this dynamic problem solution. And if we have the dynamic problem solution and we forget about the first customer for a while, we can start rethinking about this problem solution and the real value of this duo. And also we talk with them about reverse engineering. Well, I've been talking about this light buddy. Probably some of you are already designing or thinking how to create it because you haven't found it in your area. So your competition might have heard your idea and makes the same exercise. How fast will it go? How easy is it? These are important questions in that phase. But also, why did you come up with the idea? Where does it come from? And then, of course, the panic zone. The panic zone of an idea is questions about, did you do a freedom to operate study? Are you sure that this drone technology, this recognition system, can you use it? But not only from a risky point of view, but also maybe there are patents you can license, where by buying that license, you can shorten your R&D time, and you can do your development within 6 months rather than inventing everything yourself and taking 2 years until you have your final solution. Because we have to be aware that nowadays technology is moving so fast that we cannot wait 2-3 years for an idea to be fully on the market. We need to develop a kind of minimum viable product. But also in the panic zone, it's about refocusing the customer and forgetting about that first customer and thinking about other markets that might be interesting to follow. Because for me, any startup, any inventor is for me an R&D company. When an idea is born, you're still in an R&D phase. That means that you still can make things happen. It means that you can still develop kind of building blocks here. Remember the train, as I said in the beginning, you can make an additional wagon that is easy to, well, easy is not, it's not the right word, but it's doable to combine it in this R&D phase. It doesn't mean that you have to change course and you have to immediately go to a second or a third market. You can still go to the first market you want to achieve, but you already have implemented some building blocks to go faster to second or third markets, which is very important. And so if we done all these kind of questions, if we have gone through the comfort zone, the stretch zone and the panic zone, and we have answered all the questions, we come with a value proposition. And the outcome of the exercise is that we now can say that our idea is not we want a light that follows us everywhere we go. No, we say we want to bring light where light is needed. We will make something small and automatic. We will make it fully dedicated in following an object or a person that needs lighting without manual control. And we will make something that is applicable in both outdoor and indoor solutions. And we know that in indoor solutions, there might be issues with noise, but we can deal with that because we've discovered them in innovation stage. And maybe there is some possibilities, there is some growth possible there, because imagine in the industry where you have the security people, where you have these maintenance people, if they could have that kind of light that follows them wherever you go, that could be very, very interesting. And so you see how an ID from a light body has now evolved to a statement that says we bring light wherever light is needed. And maybe your final result might be something like this engineer B that has a light in it and that looks very similar to the original idea of the firefly from the beginning. And if you look at that point of view, then you see that the outcome of your ID has a whole other value and is much more viable and scalable than it was ever before your first initial ID. And so it means that we've seen with this exercise, we have some opportunities. We have outdoor applications, we have these indoor applications, we have the industry, as I discussed earlier on, but there are also some risks involved. That means that we came up with some adverbs that might be interesting to put in a patent database, which are, many of them are for free, or you can ask people to help you with this research. But we use patented technology such as drones and localization, so we need to do the freedom to operate. We need to be aware of critical patents because drone technology is an upcoming technology. So it means that a lot of people, a lot of companies will have patents on drones. If you want to create a new ID based on drone technology, it's a kind of, it's a huge risk to start building something without having done a freedom to operate study. This is very important. And maybe if you have the idea and you need to talk to other companies, you will have to build a kind of NDA agreement in order to talk with other suppliers, other companies, to fully develop your ID. But also you have, as you can feel, because you're building on drone technology, you're building on recognition systems, you might feel that you are in an area where others might have had the same ID already. So it's better that you have to look around and to see and to do the benchmarking, at least worldwide, if that ID does not exist yet. Because if you have done already all that marketing campaign and all this development and maybe prototyping to discover once you're on the market that you're making something that already exists, you have, you lost a lot of money. And also you have to be aware that your ID is located in a fast moving sector and it's based on disruptive technology. So you are in a high risk area. If so many startups that are using disruptive technology, that are building new business models based on disruptive technologies, the first thing I always tell them, please perform a freedom to operate, do a patent landscaping so that you're able to see where are the risks for patents, where are the opportunities to still patent some new ideas, some new inventions. And this is very, very important for any startup. And so, as I told you, that these IDs, and where it seems to be doable and it seems to be very easy makeable. Well, if I did the benchmarking for this ID, because I thought at the beginning, why did nobody else made it? Because for me in Belgium, there are no that kind of street lights or that kind of light bodies. And so I found somewhere in Asia, a company that develops fleet lights. And fleet lights are drones that follow a person running in open air. This company still needs 4 drones to realize it, so economically it will be not that easy viable, but you see they're already thinking in that direction, so they're moving towards your ID, and it's important to know that this company exists. And so you see with this exercise how we turn from a small ID as a light body to something as you bring light where light is needed. And you see that by doing all this research, by questioning all these kind of questions, we really have built a strong fundament for our ID, and we really are aware about the value proposition of our ID. And it's not fully dependent on that first customer. It's based on the technological value of an ID, on the innovation diamond within your ID, I often call. And this is important, and because in reality, this is the impact through this canvas, that is that it makes you pivot around your idea. It makes you think about other solutions. It makes you think about growth, about scalable, and any idea that goes through this canvas is increased 10 times just by doing the exercise. And also what is very important, it has made you think about things differently, because we are so in an automated modus about doing things the way we're used to do things. And sometimes we need somebody to tell you, hey, stop and think about it differently. Ask questions that might seem silly, but make you rethink about taking things for granted and taking things so obvious. Nothing is obvious when you're in innovation. You have to question a lot of things, and you have to have the mindset to change and to look at things from a different perspective. So that's about the impact of the canvas, but I also promised you that the canvas will give you a very good IP strategy and gives you, as a bonus plan, a patent strategy. And I told you that hidden within this canvas, we see some elements about patent claims and secret know-how. So if we now go back to the idea of this firefly we made from the light body, how will we then deal with this IP strategy? Well, if you look at at first you will have any idea, any business model, you will give it a name, and the name is protected with a trademark. But as you see the shape here on the picture, the shape is important. It looks nice, it looks special, so probably at least you have copyright, because everybody without registration can have copyright on something you created yourself. But in this case, as you're planning to make several drones and several products, you might think about a registered design. Cost-wise, these are not so expensive registered property rights. These are doable. In the Benelux, where I come from, it's only €250 to obtain a trademark for 10 years. So it's nothing compared to a patent. I also told you that the canvas will tell you something about the trade secrets. So some elements in the canvas, they talk about reverse engineering, which is important, because you need to know if somebody else sees your product, sees your invention, and he wants to re-engineer it, how easy, how difficult is it? This is something which is fundamental to know, and also fundamental later on in your decision whether you should patent something or not. It's also about your expertise. It's about knowing you are skilled in a kind of art, and you are trained in a kind of technology, in a kind of expertise that makes you go faster than anyone else that has not the same expertise. And also for me, which is important, and this is the aspect of unfair advantage. Unfair advantage is something that is used in marketing, and in marketing they call it, as a company, you have from history or from origin, you have some differences compared to your competitors. And yeah, I know in marketing they tend to change the words rather negative. To me, it's a fair advantage, and even an inventor has a fair advantage. And I can explain it with an example. I know a customer that has a company in fine mechanics that makes stents, that makes small mechanical pieces, small metal pieces, which is now evolved into metal 3D printing. But next to this company in fine mechanics, the owner of the company is very much interested in diving, and he's an experienced diver, and whenever he has some free time, he goes out and he goes on diving trips. And during these trips, he discovered that the rebreather he had and he used was not easy to use, easy to wear, was difficult below water, and he combined his knowledge about this fine mechanics and his diving experience from his hobby to make a new kind of rebreather, which immediately took some important place in the market, because he combined his unfair advantage, this combination of his hobby in diving with this fine mechanics, which he had as a professional career. And that is what I call an unfair advantage of an inventor. It's your career path, your background, the things that happened along the way have formed you as a person, have made you think uniquely at seeing things and observing things and interpreting things. And we need, as an inventor, to be aware of that, because it's a huge strength and it's part of our trade secret. And then at last, of course, we are on a technology basis. We need to talk about patents. We need to decide whether we can file, we can go for a patent, yes or no. And the thing about patents is that there also we need to make choices, and we need to choose whether we want a defensive patent to be sure that nobody can copy us, or we take a patent about tax optimization. That means that we need to be sure that we get refund whenever we, in Belgium we have a tax system that we get an 80% reduction on taxes whenever we have an income based on patents. But most important, do we need a patent that helps us to be strategic and scalable? And so for me, if you need to decide about patents, it's a balance between the IP background, the freedom to operate, to have the scalable, the link with your business model, some elements of tax optimization and defense. In what I see from experience is that it's the easiest way to write a defensive patent, but it's the most difficult one to have a scalable patent. But if you ask me, I prefer the scalable patents. If people or customers ask me to help them towards drafting a patent, I always will look for scalable options, because it's more value for your money rather than just a defensive. A defensive patent to me is a cost, and a scalable patent is an investment. So there's the difference, and that's why I'd like to keep focus for patents on the technological invention, on the technological scalability. And but then with this exercise on this canvas and this what do we need to learn from this exercise, and how do we need to look in the future to companies, startups, and other inventors? Well, let's make two easy examples. These are two Belgian companies. There's one company that made a drinking container for animals, horses, and there's one company that made a canoe out of foldable material. From product development point of view, these are two rather similar companies. The first company that says, well, my problem is that the water inside my drinking container it can be contaminated, so I need to add some photocatalytic elements to my container in order to disinfect the water inside my container so that it's still drinkable without any germs or whatever. So it's a very good product. The other one knew that I want to make a foldable canoe out of plastic material, but folding plastic once is okay, but folding plastic repeatedly is very difficult. So two similar product development companies, one on the photocatalytic concrete and the other one on foldable plastic. And then now if I ask you, based upon what I've been telling you about patents and scalability, if I ask you what kind, because both companies took a patent, what patent should you expect from these companies? Well, for the foldable canoe, if you will look in the patent, they dedicated their patent not on a foldable canoe, but on a foldable structure, on the foldable plastic, and you could use it for a canoe, but you could use it for anything else. So they have a patent on a scalable element, meaning the foldable plastic. So now you expect for the company with the drinking container photocatalytic concrete, what kind of patent would you expect? I guess you should answer the photocatalytic concrete. However, this company obtained a patent on a drinking container that happened to be a little bit photocatalytic. So they emphasize on the only application of a drinking container. And for me, it's a pity, because if this photocatalytic concrete was the first and was new, they should have had a patent on a photocatalytic concrete. And so as a conclusion for my talk, I hope I made you, I raised your interest in this Canvas methodology, but in fact for me, innovation, the real voyage of discovery consists not in seeking new lands, it's about seeing with new eyes. That's the biggest message I want to give you with my talk today. It's a quote of Marcel Proust. It's a very important quote for my business, and I hope this talk was interesting to you, and if you still have some questions, you can find me. I have my own company on technological entrepreneurship, and I guide customers, startups, SMEs, companies through their innovation process and on this balance between innovation, entrepreneurship, and intellectual property strategy. So thank you very much for your attention, and I hope we'll meet someday in real life, and we can discuss further on topics of women in STEM and innovation. Thank you very much.